Hi guys, welcome to this page of the notes. And again, what we're doing is we're working on partitioning a line segment. But now we're going to get a little bit trickier, where we're now going to look at a directed line segment where it is essentially on a two-dimensional surface, right? We're going to put this guy on a coordinate plane, and it's going to make things a little bit trickier, which you'll see here in just a second as I go through these problems. So let's go ahead and jump right into it. First, I'll sort of show you where we might run into an issue, and then how we can go ahead and deal with it. So the first one we've got for you here is the points A and B, which of course we'll need to start this problem by plotting those points. So here we go, point A, point B, bear with me for a second while I do this. Let's see, -8, -7. All right, right there, there's point A, -8, -7. Now I need point B, which is at 8, 5. 8, right there. This is point B at 8, 5. And let me do my best to draw that line segment. Ooh, I'll take that. That's pretty good for freehanding it. Now, what you could do, right, please notice, right, here's where this gets a little tricky. Because it's on a coordinate plane, on the previous page I just had a number line, and so it was real easy to just sort of assign values to it, find a distance, count to find that partition point. But here I have a directed line segment on a two-dimensional plane. So what are we going to do? Well, what you may be thinking is, well, since I needed to know the length of the line segment on the previous problem, maybe I could go ahead and use the distance formula. I'll find the length of this line using the distance formula. I can then do the same thing I did before. Once I know the distance, multiply it by the ratio, which will tell me where that partition point is going to be. But then I'd have to do like the distance formula again or something to try to find that end point. And it's starting to sound pretty complicated. Turns out there's a little easier way. Here's what we're going to do. Simply take your directed line segment and split it up into rise over run. Rise over, oh, I missed it. Jeez, I went one too high. Sorry, my bad. There we go, try again. There it is. Okay, so I have now taken my directed line segment and I have split it up into a rise and a run. What we're now going to do is simply partition the rise and then partition the run, and doing so will give me the point that I need where P needs to go on my directed line segment. Check this out, you're gonna love it. First, ratio. Well, the ratio is going to be the part that I want, 3 over the whole, which will be 3 plus 1, so 3/4. 3/4. Now I need to actually find what is the rise and what is the run. Well, the rise and the run. Here we go. My rise is, again, you just got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so my rise is 12. My run, I get 16. Okay, here we go. So to find my partition, we're simply going to take the rise, which was 12, and multiply it by 3/4. Well, again, I'm sure most of you can probably do this in your head, but if you can't, feel free to do it on a calculator. 12 times 3. Divide that by 4, you get 9. The run is going to be 16 times 3/4. 16 times 3, divide by 4. 12. So how do I find that partition point? Well, here's how you're going to find that partition point. We're going to go ahead and we're going to go up 9 and over 12. Boom. Right there. Up 9 over 12. This is the point P right here. Where is it? It's at the point 5, comma 2. So my partition point is at 5, 2, right? And he didn't even have to do anything with the distance formula or midpoint formula or anything like that, which is what we were thinking we may need to do when we first looked at it. Instead, we worked smarter, not harder. We just took our directed line segment and we took a look at the components of the directed line segment, the rise and the run. Then we just simply partition the rise, partition the run, and you go from there. Head on over to the next page of the notes and we'll take a look at another one of these problems together. I'll meet you there.